Okay, let's talk. I know I have a video showing you guys 1 is equal to 2, and a lot of you guys said it's also equal to 3, it's also equal to 4, and so on, so on, so on, right? Well, if you don't know what I'm talking about, let me show you guys how I did it. First off, we know that, well, when we have sine of pi, this right here will give us 0. And also, if you look at sine of 2 pi, this right here will also be 0. Therefore, we know that we can write sine of pi to be the same as sine of 2 pi. Great. And now, of course, if the sine of that and sine of this is the same thing, we can just cancel all the sine. I'm not dividing by 0 though. And we can just say pi is equal to 2 pi. And then I'm just going to divide both sides by pi. And you will see that on the left-hand side, we just get 1. And then the right-hand side, we just get 2. Therefore, 1 must be equal to 2. And if you want to do more, of course, you can also add it as it's equal to 3 pi, it's equal to 4 pi, and so on, right? Because sine of those values, they are all the same thing. But of course, this is legit, right? No, just kidding. Anyway, though, here's the deal. The problem that we cannot cancel the signs because sine is not injective. So let me just cross this out. So this is bad. So I'm just going to tell you guys sine of x is not what we call the injective function. So this is like one of the math big word, right? I will explain to you guys what I mean by this. It's not injective. Well, I can also tell you this is also called one-to-one. It's a smaller word, but they mean the same thing. It's like if somebody's asking you, hey, what is the word injective mean? And you say, it's one-to-one. And they'll be like, what are you talking about? What does one-to-one mean? And you can say, it means injective. Well, anyway though, this is actually a really important concept. If you know a function is not one-to-one or it's not injective, what it pretty much says is that you cannot really cancel the function. You have to be really careful with it. So here is the definition of an injective function. I will just tell you a function is injective, or also called the one-to-one. So it depends like which word that you like to use, right? It's injective if the idea is that if you have f at two different values, let's say x1 and x2. Right? So if you know these two are equal, then x1 has to be the same as x2. And this is my favorite version of this definition for injectivity. And of course, I also have to say x1, x2, they are in the domain of the function, but there's too many things to write. You guys should know. Yeah. Anyway, that should be enough. x1, x2 have to be in the domain, otherwise it doesn't even make sense in the first place. And we're talking about the function is real. All right, the other version is that if x1 is not equal to x2, of course the functions, they cannot be equal, right? And the way to see this is that you can have a graph, right? Something like this. So let's say this is f. Is this injective? AKA, is this one-to-one? Well, this is not. The way to deal with this is that this is called the horizontal line test. All you have to do is just draw a horizontal line. If the horizontal line crosses the graph only one time, that's good, but you have to do it for infinitely many of them. But you see, it crosses the graph right here, and the same horizontal line crosses it right here, and then crosses right here. If you have a horizontal line that crosses the graph more than one time, then unfortunately, this right here is not injective, right? Well, on the other hand, if you have a function that maybe looks like this, yeah, exponential function, f, then you can see if you make horizontal line, you can do however many that you like. Yeah, better. The horizontal line that you draw can only cross the graph at most one time. Of course, sometimes it doesn't even have one. That's okay. So this right here is injective. Maybe I should spell this out. So this is good. Injective. And as you can see, if you have a sine graph, of course the sine graph, because oh no, should look like this. Sine is not injective because of course if you draw a horizontal line right here, it crosses the graph infinitely many times. Okay, I have another proof for you guys. This time we'll show that e is equal to pi. And no, I'm not saying that they are both equal to 3. Check this out. Right, here we go. We know that, well, 1 to the e's power, this right here is equal to 1. No problem on that. And then we can also do 1 to the pi's power. Well, yes, this is also equal to 1. Because they are both equal to 1, so we can say this is equal to that. So far, so good, right? And then you know, of course, this is what we are going to do. Because we have 1 to this power, 1 to that power, that should mean that the powers have to be equal to each other. We can also just cancel the 1 like that, right? Anyway, though, you can just put down e is equal to pi. And then we are done. Of course, this is wrong. And now, you know how to say like why this is nonsense. Do not just say this is nonsense, because in nonsense, you can actually say this is nonsense without using the word nonsense. Well, let me just cross this out first. Of course, this time though, we will just say the following. We'll just say the function. Yeah, we have 1 to the x power. This right here is not injective. That's why we couldn't do what we did earlier, right? Just like the issue that we had earlier. And in fact, 1 to the x power is probably the worst kind of non-injective function, because it's always equal to 1 when x is equal to a real number. And yeah, nobody really look at the function 1 to the x power besides somebody who wanted to solve 1 to the x power is equal to 2, but whole different story. Okay, this is the best part. I will tell you guys the most mathematical way to tell people why we cannot divide it by 0. So check this out. Again, let's put down a couple things that we know. Well, we know that 0 times 1, this will give us 0. And we also know that 0 times whatever you want, but let's say put down 2. This will also give us 0. Because they are both equal to 0, so we can put down 0 times 1 has to be the same as 0 times 2. Now, because it's 0, right? Both of them have 0. Let's just divide both sides by 0. That seems pretty legit. And then we can end up with 1 being equal to 2. Very nice, huh? And of course, you know, this is definitely not legit. Now, how can you tell people that this is not legit? Do not just tell people that this is, you know, dividing by 0, which is bad. Don't tell people it's bad, right? You need to be able to tell people it's bad without using the word bad. Here is how we can say it. The most mathematical reason, in my opinion, right? Well, the function 0 times x. This function is not injective. That's why we cannot divide it by 0. That's it.